Alright everyone, we're going to get started today. Thank you again for coming if you've been here before, and if not, welcome to the archives. And also thank you for coming. Today we have Kevin Kovacich with us from the Anaconda Foundry, and today he will be telling us about its history. And throughout the foundry's history and up until its closure in 1980, the foundry operated as an integral part of Anaconda Copper Mining Company's gigantic industrial system, fulfilling the needs of mines and smelters as well as those of independent businesses. It served as one of the largest and most important subordinate operations, at least in terms of machines, equipment, and manufacturing. Again, thank you, Kevin, for coming today. Go ahead.
Yeah, okay. Can everyone hear me all right? So first of all, thanks for having me. I'd just like to set the stage here. So first of all, I'm not a historian or anything like that. I just happen to be the guy that manages the foundry right now over in Anaconda. And so because of that, I was tasked to give a small presentation, maybe 8 months ago over in Anaconda. And then somehow Tyler found out about that. He recruited me. So again, I've got this little quote up here, the history as best I can tell it. And I phrased it that way just because, a lot of you probably know this history better than I do. So, right, the smelter closed in 1980. I was born in 1983. So, I've done my best to piece together a very, very brief history, very brief. And I talk a little more, about the processes than the actual history. So if anyone has any questions or has any, any corrections or can offer any insight, feel free to speak up. So I'd welcome that. Again, last name's Kovacich. For you in Butte, it's Kovacich. So never forget, as a little kid over here for a wrestling tournament, they called for Kevin Kovacich, and I never showed up. I didn't know who they were talking about. So, yeah. Okay, so where's this headed? Talk a little bit about, obviously, Butte and the necessity for supply. So, the richest hill on earth, and then when there's a need, talk a little bit about tunnel manufacturing, then the Anaconda Company. We'll talk how the foundry department and how it worked, and then ACM to AFCO, which is the current business today, and then just a little bit over the current operations. So I got quite a few slides, so I'll try not to drag this out for you guys. But again, if anyone has any questions or want to go back, feel free to speak up. I do have some of the pictures are just canned pictures. They're not specific to the foundry itself, but some of them are actual photos, so I'll try to point that out. So of course, right, we're here in Butte, where the richest hill on earth is, right? Gold prospectors came to the area in the 1860s. Silver mining began around 1880. Copper mining shortly followed that. And that was really then, started the dawn of the electric power grid and the telegraph system. Then there was a need for hard-drawn copper wire. It was invented, and the demand for copper skyrockets. Now, when you're in the mining and smelting industry, right, you need ore cars, you need steam vessels, head frames, gears, pulleys, liners, launders, structural steel, you need consumables. There's a need for support for this industry. In the early days, right, much of the supply for this equipment and these consumables came from, east of the Mississippi. So, as you can imagine, right, cumbersome handling, long lead times, right, you've got the mule train up here, pulling some vessels in, I'm sure that's exactly how, this place was built, right? And so, what that showed is, with the boom in copper, massive amount of people moving here, they wanted to grow the business, right? There was room to build manufacturing, in this location. So in 1881, Shelley Tuttle established a foundry in Butte, which I believe was in this vicinity, kind of by the Sparky's restaurant. I don't believe any of it remains today except for maybe his main office building. In 1889, Tuttle began construction of a facility over in Anaconda, about 30 acres in the east end of town. Most of you have probably seen it. And what he did is he manufactured parts and machinery for the mining industry, as well as the architectural and ornamental storefront castings and things like that. So the street lamps that everyone sees, and there's castings and columns and pillars on many of the storefronts, that would have come from Tuttle. So the facility that he built in Anaconda, housed a foundry, a machine shop, a boiler shop, and a blacksmith shop. So this was the layout of the facility, and most of these buildings still stand today. What you had in this area, this was the primary or the main foundry. Over here you have the ball foundry, and then you have the brass foundry. As you would head to the west, you'd have basically the main machine shop, and then you have a boiler shop here, and adjacent to that, blacksmith shop. The main offices are kind of right in front. A lot of people think AFCO is, we've got a little storefront called AFCO Supply, and it's located right here, but the main office is just right behind that, so.
Kevin,
Yes,
in the early days, where did the source of iron or steel, did that still have to come back from?
it would still have, correct, because there isn't any iron mining, right? And maybe someone can correct me. I don't believe there's any iron mines in Montana. I believe there's some in Wyoming. I know Michigan, there's a lot of iron mining, even parts of southern Utah. But I believe most of the original iron would have had to come in from outside sources. Yeah. Okay, so the foundry department. In 1896, Tuttle Manufacturing and Supply Company had been acquired by the Anaconda Copper Mining Company. So Tuttle he was friends with Marcus Daly. He probably built the business in conjunction with Daly, and it sounds like when he was ready to retire, the Anaconda Company took it over, and at that time employed about 450 workers in Anaconda. So it was then, at that point, it was known as the foundry department, but it was much more than just a foundry. So we'll talk a little bit about how the foundry process worked back in those days. So they produced cast iron and brass components for machinery and mine consumables, as well as architectural components. This is a picture of the foundry today, and we even still have that same crane and use it. It's been upgraded in certain components, but the main structure is still there. The brass and ball foundry. So the brass foundry, it produced bearings and components, and bearing components and gears. The ball foundry produced cast iron balls for the ball mills. The grinding, or the ball foundry, basically became obsolete in the 70s when they started going to a forged product, which was better than a cast product. Okay, so it all starts with the pattern. I'll explain a little bit about how the process worked. So, one of the neat things, and people always like to see when they come over to town, is the patterns and the pattern warehouse. And there's a lot of patterns over in Anaconda, which are primarily owned by the Historical Society. But it was a requirement that you'd have to build basically a wooden model or pattern of the part that you want to make out of steel. So this was a very skilled trade. It was the pattern makers that the work that they put into this really is the quality of their components is what produced a quality part. So it all started in the beginning. Once you had the pattern made, it was time for a mold. So wood patterns would be set into boxes where a sand, clay, or water mixture would fill the empty voids to create the mold. They would mold for days straight, then pour when the floor was full. Sand and dirt came from the hillside in that time. So today we actually use an olivine sand. Most foundries use a silica-based sand, but even back in that time they would just dig it right out of the hillside and run it through a little screen plant. So once you have your mold created, then it's time to melt your steel. So you create a charge and you tap the cupola. So the cupola furnace is what they used in that time. A charge is basically the bulk of material that's loaded into the furnace to be melted and poured. The cupola is over there. They could produce 6,000 pounds about every 20 minutes. They would produce primarily gray iron or white iron. So gray iron is your typical cast iron. White iron is it's a high Brunel, it's a high hardness, more wearable iron with nickel and chrome in it. The material was high in carbon, so because you're using coke and coal to start to basically induce your melting process. There were steel alloys that were present at the time, and stainlesses came prevalent, in the early 1900s. So once you had your pour going, it was time to pour. After tapping the cupola furnace, the transfer ladle would transport the molten iron over to the mold. Temps around 2,500 degrees. So this is an actual picture from in the foundry. So those guys are big on safety, wearing their safety boots. Yeah. So once you pour the mold, you let it sit for a couple days so it would cool and you could handle it. And then it was just basically time for the cleaning process. So once the casting had time to cool, the molds would be broken apart and the castings would be ground to finish. Sometimes it would require machining. There's certain components that are associated with the casting process, like gates and risers, and most of that material would be cut off and then recycled in the process again. So
Kevin, again, looking at that picture of that gear,
yes,
was it cast in just two halves? Was that as big a casting as it was?
I'm sure that one, just looking at it, was probably two halves. But there are gears over there that are, I can picture a few that are probably near that size. So, and what they would do at that time, I believe, and I could be wrong, but they would even mold some of those larger components just right in the floor itself. So, yeah. So this is just a quick breakdown, your summary of how the molding process works, really. So, you'd start with the drawing, right? From the drawing, you would make a pattern. Okay, with the pattern, then what you would do is you put a box around that pattern, you'd fill it with sand. The sand would have a little bit of clay, a little bit of moisture in it, and then you would ram it tight. Then at that point, you would pull the pattern out, and you'd be left with the cavity that is a resemblance of your part. So typically, sand molds consist of two parts. Things have changed in modern times with 3D printing and different molding processes, but for the most part, you have what's called a cope and a drag. The drag is the lower portion of the mold, the cope is the top portion of the mold. And then inside the mold itself, you would contain cores. Wherever you had negative draft or holes or cavities, things that you couldn't pull out of the sand, you'd have to create a core that would leave the correct geometry in your mold. So this is just a little illustration that kind of shows how the cupola works. So the two cupola furnaces are still in existence at AFCO. They ran them, I think, last time in the early 80s, but now they're just kind of taking up space, unfortunately. So essentially what you would have is, you'd have a layer of flux, then you'd have a layer of, you'd start actually with your fuel, your coke and coal, and then you'd have flux and then metal, and then you would just keep layering that in there. And so, right, about 6,000 pounds every 20 minutes, that's pretty consistent flow, that's a lot of material. So what they would do in those days is they would mold, they'd probably mold for a month straight or whatever it took in order to fill the floor. So it legitimized actually, firing up those cupolas and getting enough material through there. Okay, so once you have your castings done, right, many of them required machining. So AFCO has a good sized machine shop. It was the largest capacity shop that was west of the Mississippi up to 1930. Had a max turning diameter of 16 foot and planing area of 4 foot by 20 foot. I believe that it was in 1930 when they built the Naval Shipyard, and then that replaced it as a larger capacity. So even today, we still have pretty large capacity. We're probably the largest capacity shop within 400 miles, I would say, until you get to Salt Lake or maybe Spokane. There's a couple of big machines over there. It was your typical machine shop. So you machine castings, you turn shafts, you had face components, you would plane components. Lots of drilling processes were required. That machine that's sitting right there, that's just a stock photo, but we have one just like it. It's sitting in the shop today. It's from 1912, I believe, and we still use it today. So an important aspect to any really rotary driven equipment that was in the foundry was the line shafts. So and basically what that was, and the remnants of those still exist to some degree if you walk through the foundry, is you'd have a common power source. Let's say you'd have one or two motors in a certain part of the building, and then it would drive a single shaft, and then you'd have pulleys that would come, belts and pulleys that would come down to your equipment, and clutches to engage that equipment. Okay, once you get through the machine shop, they also had the boiler shop, which refer to it now as basically the welding shop, but did the same type of processes where they would do forming, joining, rolling, cutting. Let's see here. They would build boilers, vessels, ore cars, structural steel, chute, etc. They would do fabricated plate steel. At that time, kind of pre-welding, everything was riveted together. So we even still have the remnants of the old riveter that was in place from years ago. And that piece of equipment was driven similarly to a line shaft, but you'd have basically a hydraulic cylinder that you'd have to hoist up with the weight on it. And as demand was needed, that cylinder would lower, and then you just would have to relift that weight when you needed more power. So we've got the blacksmith shop. So it was primary function was forge supply to the smelter itself. This is a real photo that was taken in the blacksmith shop. Now today the blacksmith shop really is in disarray. We had a big windstorm through Anaconda maybe 14 years ago, and it took the roof off, and it's filled with a bunch of debris, and we've repaired the roof, but now it really just sits as a vacant building. But the blacksmith shop would create the converter punch rods, ramming rods, hand ladles, pry bars, liner bolts, lots of hand tools. I'm sure they forge shafts and things of that nature. They've got some pretty big equipment in there. So those are basically the 5 departments that were in part of the foundry department. The foundry, the machine shop, the boiler shop, and the blacksmith shop. Really all of them operated up until the closure of the smelter. Now, right, that kind of brings us to the end of an era, 1970s. Right, as everyone probably knows, it was hard times for the Anaconda Company, and with the disastrous events of the Chilean properties, and couple that with the fall of copper prices. The company had a hard go of it. Arco purchased the company in 1977, and they closed the doors in 1980. So at that point in time, there were 3 men, Jim Levitraw, Bob Mackey, and Ed Strummick, who I guess they saw an opportunity, and so they purchased the facility. I'm sure for pennies on the dollar. In the early days, they saw just to make use of the equipment that they had. Along with that, right, Anaconda and Butte for that matter, right, it had a abundance of skilled tradesmen, and so they were able, I think, to lean on that, that resource, which is becoming scarcer and scarcer in today's age. But it was tough times in the early days. They took a risk. They bought this facility. They named it AFCO, Anaconda Foundry Fabrication Company. That's the name today. In the early days, they did a lot of the same things. Still worked heavy in the mining industry, but there was lots of ups and downs, and they almost went out of business multiple times. They had a big contract with Big Bud Tractor that was built up in Havre. They put a lot of money into building wheels for them, and then they went out of business. They went bankrupt, so they were stuck with all that. They were working at the Arbiter plant over in Anaconda. There was a fire over there, and they got sued by the local development. They were exonerated from that, luckily. They had a problem in Golden Sunlight. They built a conveyor that actually collapsed, and it really was a defect of a third-party engineering company. It was an engineering fault, but it tied up a lot of capital that AFCO really didn't have at that time. And so, back in those days, I think you had great partnerships. There were great relationships, and Golden Sunlight actually, more or less carried AFCO through that whole lawsuit process. keep them afloat. The picture on the bottom, that's a roaster down at Cortez Mine, down in Nevada. And so there's about 100 tons of structural steel for that project that AFCO created and assembled down in Nevada. During this, you know, when you're building big projects, you don't necessarily have a lot of money in the bank, and their bank, First Security Bank, failed. And so that created more problems. You know, they have stories of guys driving all night just to get paychecks, you know, just to get money home so they could pay the guys and things like that. In '95, they did sell the company, but you know, the sale never fully got completed. And so it returned back to the original owners, Jim, Ed, and Bob. So they developed a company called Jepco, Jim, Ed, Bob company, pretty simple. And so it was their plan to sell the company, and eventually what they did was they sold it to the employees. So in 2005, it became an employee-owned company. So currently, today, we're now in ESOP, 2005. We employ 70 to 125 employees, just depending on workloads. Right now, we're sitting at about 80 people, and we have an annual payroll, you know, about actually $5 million. So many of the same, or you know, we produce products that are in the same spirit of what the foundry department produced 100 years ago. So, you know, obviously a lot of mining related. We work for cement plants, power plants, paper mills. We do a lot of hydroelectric work for Northwestern Energy. We've got polysilicon related. REC just down the way is a great customer of ours. And then we also do non-mining miscellaneous. And we still have some of the historic stuff. You know, we have the original pattern for the lamp post and the horse head hitching post and things like that. And it's not our bread and butter, but we do produce some of those pieces and parts. So the 5 major departments today are the foundry, machine shop, metal fabrication. We also have a field construction arm where we'll go out into the field and we'll erect buildings or put up some of the fabrications that we build. And then we also have an industrial sales store where you can buy bolts and nuts and plate, things like that. So the current layout, if you can read that, it's kind of hard to read with that red up there, I apologize, but if you can picture that original drawing, you know, this is the foundry. It still is the foundry, that hasn't changed. We still operate the machine shop in the same spot. We've built a new building here, a couple new buildings, but for the most part, this is the fabrication shop or the boiler shop. The main office is in the same location, you know, as well as the store. This building right here, this is the pattern warehouse. So it's a large building that there's 4 floors in there that are, you know, full of patterns. So the foundry, we sell castings globally. We were an OEM liner supplier for a couple new mines in Mexico. In recent years, we send components to Africa, to Europe, some to Canada. We pour, you know, about 1 to 2 million pounds a year, depending on demand. We operate 4 electric furnaces and a heat treater. So we have electric induction furnaces. Originally, they operated those cupolas where they'd actually have to build the fire to melt the steel. Well, now we use the process of induction. So almost, you know, if you remember, you did this with your kids where you wrap a copper wire around a nail and put a battery to it and create a magnet. So the way the furnaces work these days is there's basically a copper coil around the furnace and it creates a flux field. You know, once you excite electricity around it and it melts the material from the inside out. So we have 3,100 degree capacity, heat capacity. Each furnace is 2,200 pounds. You know, nothing overly large. There's much bigger foundries out there for sure. The largest single casting that we can produce is about 3,300 pounds. So, and we can pour about 1,000 pounds an hour. So not quite the 6,000 pounds every 20 minutes like the old cupolas. So, and our heat treating capacity is up to 2,100 degrees. So there's just some photos here of what the patterns look like today. You know, this is kind of a modern style. It's called mill bake, so you don't require a box around the mold. It's a little higher production process. This is just an example of, this is the launder, and we've got some wear liners on the right there, where you've got, this is probably the drag of a mold, and you can see there's different cores in there to create different features in the casting. So we pour the same way they did 100 years ago, so the same building. You can see guys pouring right there. So we'll heat in the furnace will dump into the transfer ladle, and then we'll just go across the floor and pour. This is really our bread and butter right here. These these plates, this is a lot of what the foundry itself does, is just creating these wear components for the mining industry. So, you know, these are just plates that are gonna go in a chute for hard rock mining, and they're gonna wear out, and they're gonna order more and replace them.
Kevin, do you
Yes.
still have officially pattern makers?
We do not, no.
Okay,
No, that's a good.
it's
Unfortunately,
with
it's,
the computers and everything, you can do
You
it
know-
all that way?
you can, there's still a need for pattern makers. Unfortunately, when Don Swanson, he retired, I think right around the time when I started at AFCO, you know, 17 to 20 years ago. And when he retired, I just don't think they could get anyone to take up the trade. You know, had they had a pattern maker that would have been interested in doing that, you know, we still could have utilized one.
Because
But
it's
right-
a very specific skill.
It is a specific skill. Yeah, you kind of have to think backwards and inside out. You have to be good at math. You know, that was one thing back in the day, the old pattern makers, you know, really was kind of an art too, because the way you would build the pattern would kind of dictate, you know, the quality of the product you could produce.
You have to design all the screws in there,
Yep,
don't
yep,
you?
you have to
So
design
you don't get voids.
the gating and the sprues, and you have to make sure that you can feed the molten metal in the spot where when the part cools, it doesn't crack or tear itself apart, because that can happen. But, you know, it's less of an art today for certain, because they have computational flow analysis where they can, you know, analyze a pattern being poured and how the shrinkage is gonna happen and where potential defects are. 3D printing is used nowadays. They'll 3D print a mold itself, or now they even just they'll 3D print the patterns, but they also 3D print the molds. So you don't even have to mold it up. You know, a computer and a robot makes that machine. So yeah, the world's changing, it's different, but there still is a need for pattern makers. Where we get most of our patterns from is out of Salt Lake. We get some out of Georgia, some out of Portland area, but the gentleman that works in Salt Lake, he's 85 years old. His sons work with him, but you know, it's hard to beat his quality and his hand craftsmanship. So,
Yeah.
yes.
When you're using that place in Salt Lake, do you guys provide them the drawing?
We do, yes.
Back in the day, did they do that way, or
Yep.
did the pattern maker, was he responsible for?
No, there would have been draftsmen just
Oh,
as
okay.
well, and they would have created.
You
and
would have created a drawing.
no one would have created a drawing of the pattern. So
Oh.
just the part, and then the pattern maker would take the drawing of the part or the component, and then they would build the pattern, you know, off of their knowledge of knowing what was required to make a pattern, essentially.
So they'd have to know the shrink everything?
Yep. Yeah, that's one thing, and I skipped over that, I apologize, but, you know, one thing pattern makers have to utilize is called the shrink rule, right? So everybody knows when you heat up metal, it expands. So the pattern makers have to build the patterns oversized so that when the shrinkage would occur, when the cooling would occur, it would shrink down to the right size. So they had different tools for doing that. They had special rulers that were oversized. So 12 inches on a shrink rule for stainless steel, you know, would actually be like 11 3/4 in real life, things like that. Heat treating capabilities today. So we don't get too sophisticated with our heat treats, but we do annealing processes, normalizing, quenching. We do some tempering, some quench and tempers, and some aging, stress relieving. So some of the manganese steels, which are high impact resistant material, they come out soft, so they need to be quenched so that they're ready for service. Alloy steels usually come out high stress induced, so they'll need a tempering or stress relief process done to them. So our heat treater, you know, it's one of the busiest pieces of equipment in the foundry. So looking towards the future, so building for automation, you know, to stay with the times. We're actually in the process of implementing it's a semi-automated molding line that we're building that hopefully, you know, if we can legitimize it, go full automation on some aspects of what we do over there. So.
Oh, Kevin, are you the company building that, or is that something you buy off the shelf?
No, you buy that off the shelf.
Oh, okay.
Yep, and the company that we're using, actually the components come from England. Interesting enough. And it all really comes from the East Coast, Ohio, Pennsylvania. You know, that's where all those suppliers are. So. Okay, the machine shop today, so we have manual and CNC capabilities. We still have large part capacity, and it isn't integrated with the foundry and the fab shop. There's just some pictures of our current CNC milling machines. A little different than the equipment they had back in the day. We program a lot of this in the office, and the guys will run the parts out in the shop. So this is there's 3 pictures here. If you can tell how it's broken up, it's kind of hard to see maybe, but this is how the machine shop looks today. This piece of equipment is from 1912. So we've got a part on there right now. It's a component for Montana Resources. So, and that does have the ability to turn up to 16 feet, but the table that's on it now is around 8 feet.
Kevin,
Yeah,
will handle 18 feet.
16 feet.
We had 18 feet on it. The outside diameter of a roaster, the wheel was 18
It was
feet.
18 feet.
Yeah, but I mean,
Yeah.
it
Barely
was
fit, yeah.
squeezing it. Yeah.
Well, and actually, if you know, the structural support for the machine, you can see where someone took an air arc to it and carved it away so they could fit a bigger piece of it.
But that head slid back is what it did. So you get bigger diameter. And
Yeah,
if that picture moved over just a little bit, there's the table that went on top of that.
yeah,
Kevin,
I know. Well, it might be in here. Hold on. No,
No, it's not.
Yep. This is just, we produce pieces and parts like this today. So, still, this is a large trunnion shaft, so still doing large stuff. We're very much a job shop. We do lots of onesie twosies. We're not really a production shop. So we've found a niche. There's a lot of machine shops around the world that are production shops, but we've got our niche in doing kind of one-offs.
Now, Kevin, that great
Yes.
big shaft,
Yes.
do you cast that, or is it?
No, that's
Shaft, you buy a rough shaft?
Yep, we buy a rough
You
shaft.
turn it,
Yep, and that's a 4140 forged shaft. So that
Okay.
comes in as a forging, and that actually comes out of Ohio. So now we move into the fab shop. So we operate a metal CNC shape cutter. We do structural steel fabrication. We fabricate ducting, tank spins, silos, hoppers. I've got gas module fabrication. I'll touch on that in a minute. Again, talking about how we're also a job shop in the fab shop. We do lots of one-offs. So, someone can come by, and if they're looking for something to be welded together, we'll do that. And we sell most of these products around North America. So just pictures of our computerized shape cutter. It's the workhorse of a fab shop. The components are drawn in the office, and then we cut most of the pieces apart. And then the fabricators and the welders kind of put the pieces together like a puzzle. Back in the day, right, the old craftsmen, they'd have to lay out all these pieces apart. Yes. And so unfortunately, modernizing has taken away that skill somewhat. And so it's hard to find people that, how can I say this? Just that level of craftsmanship is gone, unfortunately. So, and we did it to ourselves, but really with automation. So we have a computerized press brake. So when we're bending and forming pieces, it helps you do that, and the pressures are equal. And we have a computerized bandsaw for cutting our structural steel to length. We build stuff like this. These are actually 2 biodiesel tanks that are out at the Dave Gates power plant. This is a beet unloader for sugar beets in eastern Montana. We build these are stainless steel tanks. We do stuff like that. This is for the cement industry. That's a cooling hopper. We do structural steel. So we fabricated the steel that you see there. Then we also erected that. That's down in Dillon at Barrett's Minerals. We have our contract shop, which is actually located just a few blocks away. So I don't know if anyone's looked up there, it's on Anaconda Road, just right over here. We've got AFCO painted on it. And so we own the buildings, the property is still owned by Butte. And what we do there is we produce gas module equipment for REC. So got a better picture. There's a picture of a module right there. So that shop primarily just works on that component. And what that is...
That's the trailer that carries that gas?
Correct, yep.
That silane gas?
Silane gas, yep. And so they transport that around the world. And every 5 to 10 years, depending on the inspection type that's been done to the equipment, that has to be rebuilt. So there's kind of a constant churn of those modules. And if anyone, occupies this space in Uptown, you probably see those going back and forth frequently. So field crews, we're licensed in 5 states. We do equipment and plant maintenance and repair. We do pre-engineered metal buildings, structural steel erection, and we also do concrete installation. So these are just a few examples, some of the buildings that we've done. This is actually for Stillwater. This is for the mine that's outside of,
Columbus.
not Columbus, but this is on the other side. South Boulder, yes.
Yeah.
Yes. We erected the building and installed all the equipment. This is a pump station down in Thompson Creek, which is in Idaho. What you're seeing here, this is the optical sorting machine down in Barrett's. Yeah. We do a lot of hydroelectric work. So this is Hauser Dam, and what you see there is it's a Francis turbine assembly that we're hauling across the dam for, we did some rebuild work. We're also in the process of installing some new and modern Kaplan turbine equipment for Northwestern Energy. That's at Hauser Dam as well. That's a new intake pipe for one of the Kaplan turbines. So we just did a project down in Madison. This is 2 years ago. Installed a couple horizontal turbines as well. So we also have engineering services. We do 3D modeling. We do 3D scanning. We'll create drawings like this. A customer will come to us with a need, and we will do this aspect of it. Let's see here. I'll skip through. This is an example of 3D scanning. So we talked about kind of craftsmanship going away. And we have some equipment that this is a casting for a gyratory crusher. This is called an arm guard. And so we went down to Arizona, and rather than bring your tape measure and all that stuff and draw it up, we just 3D scanned it, and then we've got the part, and it makes it a lot easier to recreate. So that's also a rendering of a liner that we scanned. Yep, and then we also have the store, again, where we supply, we sell bolts and nuts and miscellaneous steel. So that's really the end of my talk. Hopefully that was coherent enough that you guys could follow along.
Kevin, would you,
Yes.
you just mentioned that dam. I know that
Yes.
was quite an emergency procedure that you performed over there at AFCO. Would you kind of go over that?
Yeah, well, and that was at Hebgen Dam, and what had happened there is they put in some new operating gates, because Hebgen is basically the head of the whole Missouri drainage, and they've got a plethora of dams on the Missouri that they operate. And so what had happened is just a gate coupling had broke. Their position sensors were above where the broke occurred, so the indications were that the gate was open, but the gate had sucked close. And so all we did was we just did our job. Luckily enough, we had the material, we had the equipment, and the people that knew how to do the work, so we were able to make a part work overnight. They were able to get it installed the next day and then get that gate back open so they could restore flows to the Madison River. So
Weren't they out, have people picking up fish because
they
the water
did,
was
yes,
so
yes.
low, and if you guys wouldn't have got that before, it would have had a major
Yeah,
catastrophe.
no, appreciate that, and we're just fortunate enough that we're in the right spot at the right time, and all we did there was just our jobs, so it worked out. So yeah, AFCO. The foundry department, it's an industrial legacy, 1889 to the present, 130 plus years of operation. And we're still doing the same work that they did 100 years ago. So does anyone have any questions or comments?
You mentioned Thompson Creek.
Yes. Yep.
That Chalice mine?